Hello everyone, welcome to my channel. In this lecture, we will discuss about the effect of thermodynamic model on the condenser and reboiler duty. We will also discuss the effect of thermodynamic model on the distillate and bottom composition. So we will use sponges and we will use a mixture of ethanol and water, and we will discuss that how a thermodynamic model can affect the condenser and reboiler duty as well as the composition of distillate and bottom product. So first of all, we will open sponges. This is the sponges. This is the component list. Click on add to add the component. So our mixture consists of ethanol and water. Ethanol and water. Click on fluid package. So first of all, we will select NRTL fluid package. So click on add and here select the NRTL fluid package. Non-random to liquid. Click on this fluid package. Okay. Now go to simulation. Click on simulation. This is a model fillet window. Click on the material stream. Drag and drop this one. Then click on separator and click on the distillation column. Drag and drop this one. Now close this one. This is our feed mixture. Okay, the name is, I will rename it to feed. Feed, the feed is, suppose it is entering at 25 degrees centigrade and 1 atmospheric pressure. The mass flow rate of the feed is 1000 kilogram per hour or 100 kilogram per minute. 100 kilogram per minute. The composition of the feed is, suppose the feed consists of 60% ethanol and 40% water. Click on OK. So it is OK. Now the feed stream is fully specified. Now double click on the column T100. By default its name is T100 distillation column. This is the condenser energy, so I will name it QC condenser energy, and this is QR reboiler duty. This is the condenser duty, this is the reboiler duty. The condenser is total type condenser, and this is the top of the distillation column. This is the bottom of the distillation column. Now connect this inlet stream. So feed is entering to distillation column. There are 10 number of stages and the numbering start from top to bottom. And the inlet stage is 5. The feed will enter to the distillation column at stage number 5. Click on next. And the reboiler configuration, I will use the once through reboiler type. Click on next. And the condenser and a reboiler pressure. So suppose the condenser pressure is 0.9 atm and the reboiler is slightly higher pressure, is operating at slightly high pressure, so 1 atm pressure. Click on next. This is optional, so click on next. And this is the reflex ratio. So the reflex ratio is, suppose the reflex ratio is 2.4. Click on OK. Now it shows unconverged, so we will go to monitor, and this is the reflex ratio. The distillate rate is not specified, so I will uncheck this one, unactivate this one. Now the degree of freedom is 1, so I will click on add specification. So click on column component fraction, add specification. Now this is the stage, so this is the reboiler. Click on reboiler and 99% water will coming out from the reboiler. So the mole fraction of water which the mole fraction of water from in the bottom product will be 99%. So it is in liquid form and the mole fraction of water is 99% water. Okay, this is water. Okay, now click on run. So it is converged. It is converged. Now this is converged. This is the top of distillation column. This is the condenser energy, the reboiler energy. This is the bottom and this is the feed. Now click on the top product and click on composition. So here the composition of ethanol is 80.99% ethanol and 19.01. So it is about 81% ethanol and 19% water in the top, in the distillate. In the bottom, you can see the composition of ethanol and water in the bottom is it is about 99% water and 1% ethanol in the bottom of distillation column. So now the condenser and reboiler duty. So click on distillation column and here go to this is the internal rating performance and this is the condenser and reboiler. Click on this one. So the condenser duty is this is the condenser and this is the reboiler. Condenser duty is 1.69 multiplied by 10 raised to power 7 and the reboiler is 1.814 multiplied by 10 raised to power 7 kilojoule per hour. So now close this one. Now go to now select another fluid package. So click on property. First of all, we have selected the NRTL. Now I will select some other fluid package like I am using the Wilson equation of state. So I'm using this Wilson fluid package. Click on this one and now click on the simulation. So S1 says, do you want to lift and holding mode when entering interactive simulation environment? So click on yes. So it is on hold mode. Now click on activate. So now go to the top product and check the composition. So now it is slightly changed. It is 81.58. The mole fraction of ethanol in the top is now it is slightly increased and the water is slightly it is also slightly increased. So first of all it is decreased. Water composition is decreased and it is increased. Ethanol is increased when we used the Wilson equation of state. Now go to the bottom and check the composition. So here it is 99% water and 1% ethanol. Now double click on the column and check the condenser and reboiler duty. So now it is slightly changed. It is now 1.68 multiplied by 10 raised to power 7 and it is slightly changed. The condenser and reboiler duty is slightly changed. So this was all about that how the equation of state, how the thermodynamic package can affect on the condenser and reboiler duty and how the thermodynamic package can affect the distillate and bottom composition. Thank you very much for your attention. If you are new to the channel, please like and subscribe.